Yeah, please.
Okay. Yeah, please. Yeah.
Awesome. Thank you so much for the kind introduction, Henry. So today I want to show you guys what our platform does and also get a little bit of feedback from you guys. Has anyone attended like MIT's iQuack or any of the hackathons such as QHack in this audience? Maybe, maybe not. At these hackathons, a lot of times you, for example, need to have a very quick way of setting up your environment for quantum computing. For example, you may need to have, for example, like Circ and open fermion for quantum chemistry, or another good example with a lot of dependency issues could also be TensorFlow Quantum, as well as TensorFlow and Circ. So these are some of the maybe prominent software packages that don't talk well, and at an environment and even on your daily usage for working with quantum computing, it's super annoying, for example, to get all of this set up. And another one that might be super annoying to set up is like qQuantum and getting their Docker image set up on a GPU. So what we do at qBraid is we set up all these things for you that it's super easy for you to get started on any of these platforms. And so today I'd like to show you first our GPU side, and then secondly, I'd like to show how easy it is to submit quantum jobs and our SDK. Then I'll hand it over to Mert, who will talk about his product as well. All right, so with that said, when you sign in, you'll be greeted by this page where you have all of your files that you've created. They're mostly notebooks accessible here, where you can double click, and these icons, this is the qskit icon, where it will actually tell you that this kernel that you're running is the qskit environment. And with that said, we also provide the ability for you to check your quantum jobs on your account page, hackathons to attend as well. And we also have courses that are available for you to deploy if you're interested in learning more. I think most people in this audience probably know a lot about quantum. I think that would be my best assumption. So maybe the courses aren't for you, but hopefully some of the resources we provide would make your days a little bit easier when you're trying to code in a specific quantum software. So with that said, right here, you can actually see what kind of compute we offer. So we offer 2 virtual CPUs all the way up to a GPU, as well as specific images to run, such as Julia's blockade. That's a convenience you get. So you don't have to set anything up for Julia. If you're not familiar with blockade, for example, all you do is just create an account, and then you're just able to deploy various software. So I'm going to show you what that means right now. So I launched my lab, my server has started, and I'm able to open up my container here with the GPU. And as soon as that is ready, I will be able to then just show you a quick example, for example, of Q-learning, which is not quantum related, but how easy it is that you can simply pick an appropriate environment here. And for example, I have it in my qskit environment, which is compatible with PyTorch. And you can actually add packages here that are correct to the specific version. And actually, it should be Torch. So you can actually add the specific version. I've already added mine, so it's all set up. And you can also enable quantum jobs from this environment as well. Some additional feature you can get for creating these environments is that you can also have customized environments that you can create that you can also share with others. So for today, I'm just going to show you how in this environment, it's already been activated. So you have to first add this environment in from this side. For example, if I want to work with IonQ, I would click that. And then it's installing. While it's installing, I will show you that once it's installed, just like this qskit environment, you click activate, you select the kernel that you're interested in, which is the qskit one. And once it is now idle and ready to go, you're able to just simply start running this. Oop, I don't need to install this, but you're able to then just import all of your necessary packages and just start running your notebook just like that. And the fact that it's shareable means that you can share a specific environment with someone and the notebook and make sure that they get the exact results that you're looking for. And you don't have to worry about, say, OS issues. Maybe some person is using Windows, another person Linux, a Mac. No, all of those dependency issues, these OS issues are resolved because everyone is using qBraid. So that is some of the features that we offer, and you're able to get an accelerated experience using PyTorch. And you can actually confirm that you're using a GPU, for example, with the code snippet that I can search up here, which can verify that the GPU is available. Oh, I guess it's not available on this image, but it technically is available, and you'll be able to run on a GPU. So with that said, yep, and then we did have a tutorial by one of our former interns, Han Zheng, on, I think it was quantum machine learning, where at Argonne, thank you, Jamie. So it's like super easy to set up, and you're able to essentially walk yourself through various resources. And if you're unfamiliar with any of the, for example, if you're unfamiliar with the quantum software, you are able to access their tutorials that we have already available, which then you can run any of the available algorithms from the tutorial as well. So you can import qskit, then start running circuits as well and learn more about it. And finally, we also provide a quantum documentation for you as well, for you to learn more about each of these software. So with that said, I'd like to also show running quantum jobs is super easy. I'm going to stop my server. I'm going to start it again. And launching your server is super easy. So I'm going to pick my standard one.
You like that, Joe?
And you'll be able to then deploy a new image from here as well. It does take a little bit for our pods to scale up, but once it's scaled up, it's actually very convenient. Because once again, a lot of these are available.
Yeah, I'm in the office now. Thanks. Thanks for calling me back.
Just a question out for the audience as we're waiting. Like, have any of you guys kind of faced a lot of dependency issues, for example, with qskit and when they're moving job providers? Have you guys faced anything with like running Amazon Brocket, for example? It can be kind of difficult, for example, just to see when quantum devices are available, or sometimes you have certain circuit frameworks that you want to access in qskit, and then you want to use PyQuil as well. So while the pod is scaling up, I'd like to show you guys one more thing that we have, which is our repository for a open SDK. It's an open source SDK, which will allow you to essentially transpile quantum circuits as well as execute them on various backends. So some of the languages that we support are Brocat, Cert, qskit, PyQuil, PyTcat, as well as QASM2. You can write your circuit once, and then you're able to submit it to various backends that are, you can also check for their status and also check which ones are available as well. You can access this locally. So if you want to use VS Code, you're able to also use your API key and run a session from qBraid API, code in, for example, qskit, and then submit jobs to IBM, as well as code in any other framework that you see here. So you can code in Circ, PyTcat, QASM2, Rocket, and transpile it. So I will be showing a quick demo. Once that my production image is pulled, I'll be able to show you guys a quick demo of one of this qBraid lab demo. So let me pull it up here. And one of the nice features we have is public repositories are able to be cloned very quickly with this button here. So Just going to double check that it's pulling still. And once you come here, you can click on it. You're able to then launch this specific repository. And once the image is pulled, you'll be able to see the repository is opened up on your own account. And another nice convenient feature is that once like an image is pulled, it does take a little while if you're using a new account, but once it's pulled, you're able to then, it usually just starts in essentially under a minute. So, all right, notebook is started. Panel server. And I should be able to view the state. There you go. And essentially, I'm able to then have a tutorial, for example, with AWS Quantum Jobs here. And what's nice is from this, the qBraid lab demo, I'm able to actually just take myself with that button to that repository. So if I click again, it will clone, and you're able to see that it takes me to the same page. But what's also nice is that it will detect the exact kernel that's needed here for this and for AWS Quantum Jobs. I just have to run qBraid jobs enable, and this is our own CLI that we built that allows you to then run commands here from your and access quantum jobs, access your credits as well as see which environments that you have on the left have quantum jobs activated and more. So let me just reset the kernel. What's going on? You double check. And if something like this ever happens where your quantum jobs or your kernel isn't quite connecting, I recommend just kind of refreshing your page. And usually all of these will be fixed. It's usually just a WebSocket connection that's just being a little fickle. And you can actually get this kind of issue often on regular Jupyter as well. Okay. So while that's connecting, not entirely sure why it's taking a little while, but you're able to enable quantum jobs. Usually, if you had to work through Amazon, you have to create IAM roles, you have to create a ton of S3 buckets and enable a lot of overhead for cloud. And with qBraid, you don't have to, you just have to run this one command. Then you're able to view which jobs, which environments have jobs running, check the amount of credits. You can run a simple bell circuit on an SV1 simulator, view the jobs that you've ran, and then you're also able to just submit jobs that simply, and then view which ones you've ran here on your jobs, and also check which devices are available. All right. And then for the qBraid SDK, I'd like to also show that you're able to enable jobs as well on the SDK, import it, and you're able to see which devices are also available. Shift through, filter through whichever kind of modality you're interested in, as well as the number of qubits. And you're also able to then create a quantum circuit in, so for example, Google Circ, then submit the job that's written in Circ to an AWS device or an IBM device. And you're also able to then get your jobs and then get your results as well. So I think I was fooling around here, but this is some of the things that we allow you to do on qBraid. And what's happening when you're submitting a job with a quantum framework such as Circ to another device on a different quantum framework, you're essentially doing a CAC decomposition. And when you have one circuit, we're doing the exact mapping of the circuit from one framework to another. And then if there are any custom gates, as I said, we're doing a decomposition as well to make sure it's available on the basis gates that are available on a different framework. Yep. So that is kind of what we have available. Does anyone have any questions? Not, I would probably hand it over to Mert, and he'll talk a little bit more about his work as well.
I have a quick question.
Yeah.
Does qBraid has any like pulse level access?
Pulse level access, yeah. So you're able to kind of code in Qiskit. So the environments that you have here, for example, that available, you can code in Qiskit at the pulse level. This is just vanilla Qiskit that you have. So you're able to do whatever you like here. We also have, so essentially you can think of these as Python environments. So all of your work that you do locally, you're able to do on qBraid.
Okay, thank you.
All right, off to you, Mert.
Yeah, thanks, Ricky. Great presentation on qBraid. Okay, so I can go ahead and get started. Hi, everyone. I'm Mert. I'm with Icosa Computing. We have a few more team members here. So if I may, maybe I can ask you guys to introduce yourselves as well. So let's start with John.
Hi, everyone. I'm John. I've been working at Icosa as a software engineer and helping lead software efforts.
And we also have Joya.
Yeah, hi everyone, I'm Jiayue. So currently I'm an intern at Icosa and mainly focus on the finance part.
Yep, and we just hired 4 interns this summer. We're growing our team. So if you're interested in opportunities at Icosa, please feel free to reach out to me. We're working on very exciting projects. I hope Jaya is having fun this summer. But yeah, so we can go ahead and get started. I have a few slides and I'm gonna go ahead and do a demo on how we do the model tuning, which was described in the company intro. So let me share my screen. Oops, okay, here we go. So our goal is to build optimization software for the real world. And to do that, we are actually utilizing quantum physics. Currently, quantum physics is an amazing resource, but it is being underutilized to solve the hardest computational problems facing us. So one of the most important computational problems is optimization. And optimization is everywhere. Every part of our lives involves in some sense optimization. As human beings, we actually optimize our decisions. The brain works with optimization to make decisions. But what we're focusing in Icosa is these new tools coming out from quantum computing, which qBraid alluded to before our presentation. Not just in hardware, but also in algorithms, so quantum computing algorithms, and also quantum-inspired hardware, which I'll discuss in a bit. But these models or these methods are not accessible and they're not tuned. They are becoming more and more accessible thanks to companies like qBraid, as Ricky just described. They're trying to make these resources as accessible as they can. And what we're focusing on is actually making them relevant to the real world by tuning them, by tuning the models that that we put into the hardware or the algorithms. And one specific problem we focus on is called discrete optimization. And the world is discrete. So I have 5 discrete fingers in my hand. We have discrete objects that we interact in the world. So let me give you a very, very simple example. And if I'm making things too simple or maybe too complicated, please interrupt me. We can do this as a discussion. But let's say I'm trying to maximize my vitamin intake for the day. I want to be healthy, but I don't want to take too much sugar in. So one thing I can do is I can create myself a fruit bowl for the day. But if I'm doing a discrete optimization, I can only have whole fruits. I can have 3 lemons in my fruit bowl for the day, and I eat the whole lemon. On the other hand, I can also make a smoothie. So in that case, I don't have to put the whole lemon in. Maybe I just want 2 teaspoons of lemon. So that is allowed in continuous optimization. And continuous optimization, because of that ability to do fractions of variables, is an easier problem. Actually, it's easier theoretically. Discrete optimization, on the other hand, is harder to solve. 2 reasons. One, we don't have theoretical grounding to do these problems in polynomial time. And the second one is there is no solver out there that allows us to tackle these problems effectively. So that's why we decided to build one at Icosa. So we bring in these quantum physics resources, and we allow them, we translate them to be applicable to the real world. So these resources, they allow us to solve much larger problems, but they become relevant when the problems that we put into these resources are tuned. And we operate currently in finance. So we bridge the gap between finance and these quantum solutions. Our first product captures live data, and we trade every day with it. We do the optimization, and then we can trade in minutes. I'm not going to talk too much about this, but one key difference between quantum computers and quantum computing research is that quantum computers are just right now on hardware, and they are not available today. They are available in the sense that you can do experiments on them for research purposes, but unfortunately, there's not much we can do with them today that is practically relevant because they're still a developing technology. On the other hand, quantum computing as a science, as an industry, has inspired new resources, and this is what I call quantum computing research or quantum computing algorithms on the software side, and quantum inspired hardware on the hardware side, where people have built specific chips, specific hardware to solve these kinds of problems. In our case, it's discrete optimization, and we use nearly unlimited compute hosted on AWS, thanks to their startup support, to tune these resources. So we get live data every day in the market, near the market close. So if this presentation was around New York's market close, we could have traded live with you guys, but unfortunately we're too early for that. But we trade every day near the market close. So we get the data, we feed it through these modeling that we do, and I'm going to talk about the model tuning in a bit. We feed it through the solvers that I just discussed, the quantum resources, and reach an optimal solution. I think this is an anneal or long portfolio that we did a few days ago. What's important here is we tune the parameters with artificial intelligence or machine learning. So we have 24/7 tests running to test out what could have happened back then in the past, so that we train our model so that it can predict a valuable solution for the future. So sometimes you have a magical solution, you have a quantum inspired hardware, maybe you have a magical quantum computer that no one knows about, but if you are giving it a wrong question, if your model is not right at this level, you're not going to get a valuable answer. So in more technical terms, maybe you are finding a solution to your energy landscape, you're finding the minimal point, that's good enough. Or maybe you're even finding the optimal point, the global optima. But if your energy landscape is not correctly created, it's not gonna be practically relevant in the real world, meaning that it's not gonna make you profits the next day in the market. So okay, a lot of talking. So let's now play with the demo. Even before this, so I'm gonna explain this while I load the data because it takes a few minutes. We have a lot of tests that ran in the background. Let's see. Let me share my screen again. Feel free to ask any questions if you have any.
Yeah, actually, I got a quick question. In the previous slide, they mentioned like Icosa quantum translator. I'm curious what this quantum translator doing, like translate what to what.
Yeah, of course. So I'm actually, this is great timing. So I'm gonna explain that in the next minute. Let's start loading the data. So here we choose a solver type. Again, qBraid discussed a few different quantum resources out there. For today, we're going to use our simulated solver because we're running this in a very small problem, which is SP500. But I think most of you here are from finance, so you can actually look at, for example, an energy SP500 energy, which has 23 stocks here. But let's look at the whole SP500. So I'm loading all of SP500 up until yesterday. So these are the prices. So these are a few benchmarks you can play around with. Just as a disclaimer, I'm not going to get into the very details of the product for confidentiality reasons, also because of the audience we have today. So it's going to be mostly talking about finance side of things. But if you're interested, or if your institution is interested in trying out our product, please reach out to us and we can make you on a more comprehensive, in-depth presentation on how things work. So let's pick the dates from the beginning of this year to a few weeks ago. And let's load the dates. Okay. Now, this is going to take around 2-3 minutes, but we have around 1,000 tests for each possible tuning we have to create a trading trajectory. So I'm going to get into this now, which is a good time. Oops, I'm running out of battery. 1 second. There we go. Yeah. So I think this is going to answer your question as well. So what does the translator do? So we have a optimization tool that I just discussed. So these resources are very powerful on solving discrete optimization problems. The thing here we need to note is these solvers are not very easy to use. But that's not our differentiator. That's not what Icosa exists. You can always educate yourself, and there are other companies out there that educate the workforce on using these resources. So that is not our key differentiator. Yes, these resources are not very easy to use, but you can teach yourselves to use these resources. The second layer of our product, and this is where the first layer of the translator is that you take a real world model and you turn it into a discrete optimization problem that is feasible to the solver. That's the first layer of the translator. The second layer is these models, they have many parameters that you can tune. One example parameter is the scaling between a linear term and a quadratic term. So imagine a graph of assets. I'm going to give a very basic example. Your nodes are each asset's projected return for the future, and the edges are the correlation between those nodes. So the ratio of how much importance you want to give to the returns versus the covariance or the risk or the correlation, whatever risk matrix you're using, is a parameter that needs to be tuned. So this tuning is done by, again, a lot of parallel search, and a machine learning model that we created allows us to tune the model in such a way that it brings returns the next day in the market. The last layer we also built in this translator, again, we translate quantum to finance. You can think of it this way, and allows the trader, the portfolio manager, or even the quant researcher to make a choice. We also put in this element of human choice. It can be remote. You can go fully autonomous, and the machine learning model can do it for you. But we allow the researcher also to make a choice. So that is the outer layer, I guess, of the onion of our triple layered onion of our product. Let's see if this is loaded. It is loaded. It took 2 minutes, but let's see the data so you can visualize. So this is just the second layer yet, but you can see here like around 1,000 different tunings we can put into our model, and each produces another trading trajectory that specifies how much you want you to put into Apple. So it's like $40,000, $42,000, $55,000, right? So the portfolios change, the trading trajectory change, and you can look at how the port. So this, for example, this tuning created from $1 million to $1.5 million in 4 years, which is not great because SP has been going up. So this is just one tuning, and we gotta now choose which of these tunings to use every day in the market. This changes every day. This is dynamic. So how do we choose what tuning to use? So now let's play a game. So now I want someone from the audience to be a trader for me for a bit, to make choices, and then we can compete with our trading strategies. Now this is the last layer. Remember, I gave you this strategy selection execution part, where the third layer where the trader makes a choice. So if someone can maybe like give me, and this can be random, just like give me names on what you want to maximize. How do you want to choose the tuning? Meaning, what is important to you as a trader, as a firm, whatever, that you want to maximize or minimize over. So you can minimize the variance, you can maximize the Sharpe, you can maximize daily return, or maximize cumulative return. So can someone give me just like one of these names? What do you want to look over? I think there's someone from Sharpe. Sorry, someone from chat said Sharpe. Okay, let's do that. Okay, yearly Sharpe. Here we go. I guess you want to maximize this. QW put this in. You want to maximize, I suppose. Okay. So do you want to do this over a longer time period or a shorter time period? And here, the larger time period goes from 31 to 100, and the shorter time goes from 2 to 30. Meaning that out of all possible tunings for your model and all trading trajectories, which one do you want to choose? You want to choose one that maximizes your, okay, we got shorter from the chat. Okay, shorter. And how many days? So here we're doing, out of all these 839 different possible models, you're choosing one that maximizes the Sharpe over a shorter time period. And if you can give me a number between 2 and 30. And it's going to be random. So like you can shout out 7. Okay, we got 7. Now, we also have filters where you're trying to beat SP500. That's the goal. So at the larger time period, you can also have filters where you want to filter anything that doesn't beat the Sharpe of SP500 or the cumulative return of SP500. Do you want to do this filtering, or do you just want to go and just maximize yearly Sharpe over 7? So the question is, do you want filters or not? No filters. Okay. Thanks for QW for the input. Okay. Now I'm going to choose one that is pretty decent. So I think I already put this here. Yeah, I already have it set up. This is a decent strategy that we tried, but I'm going to tell you the caveats as well. So as you can see, there is no more quantum anymore. It's all finance. It allows the trader to have an opinion about the market and choose every day. Actually change this also. This can also change every day, not just the tunings, but the most outer layer, the collection criteria can change every day. And let's now make our methods compete. Maybe QW can create a strategy that is pretty good. So the orange is QW strategy from the audience. Purple is what I put in, and gray is SP 500, the benchmark. So we're trying to beat the gray. Gray is just the overall market. And that's what our product does, actually. We track SP 500 every day. Now we're choosing stocks out of SP 500, but we're trying to choose the best stocks. And this best stocks, it's a very, very ambiguous term. What is best stocks? We created this triple layered product so that we know exactly what we mean when we say best. And as you can see, the purple is beating the SP 500. Unfortunately, orange is kind of below the market. Of course, it's hard to like just guess these things. So we do extensive research on this to decide how to select the criteria. So this is going to go up until like a few weeks ago, until June. Maybe does anyone have any questions? So right now we're in April 10th. And this is like not just a back test. So this is actually trading every day without knowing what the market is the next day tomorrow. And of course, the real market is different than what you can do here, because there's transaction costs, there's slippage, many things that we actually consider in our trades. So this is just, again, a demo. Happy to provide a more in-depth, in detail review of our actual trades to interested companies. Oh, there is a big drop on orange. Unfortunately, QW, there is a this is like a big drawdown. But yeah, so as you can see, the purple has done well. And this is actually what we've been doing for a while. So we trade on these strategies by effectively picking good strategies, by going over different possible selections for these. But there's a problem. As you can see, there's a drop here. This is still static. This is still, I want the same opinion. I have the same opinion of the market every day. So as you can see, this is actually done around May, near the end of May, beginning of June. The reason for that is we have a question, sorry. So the Sharpe ratio is not an accountable parameter for maximizing return. No, we can't. Okay, we can't really make that overarching claim. So the question was, okay, maybe Sharpe ratio is not great at beating the market. No, we can't make that overarching claim, because as you can see, we include Sharpe actually in our filters in this more complicated strategy. So anything that doesn't beat the Sharpe of SP is removed. On the other hand, we are out of these selections, we choose the one that maximizes cumulative return. But this is only good for this time period for now. This can also change. Markets change. So what we implemented is actually now a machine learning technique. So this, now I'm on a new notebook. I'm not going to run this because this takes up much more time. But you can see from that time frame around where that time frame ended, beginning of June to today, we've been using this purple, which is a machine learning strategy. Now the machine learning does this selection for us. It selected what criteria the market would most respond well to. So we put in every day the market characteristics to our model, and we tune our model every day to get this output. We have another question. How often do we change the parameters manually? And what's the typical trigger of change? Yeah, that's a great question. Let's see. So this strategy was changing it quite frequently. So so in the last 10 days, these were the tunings it chose, and it is changing. Not a lot, but slightly. And I can't get into details of what these parameters mean, but the parameters change, the actual tunings change. The model needs to be tuned every day because markets change. But yeah, we have around 12 minutes left. But all of these respond to a different portfolio. Actually, it made a very dangerous choice. In the last 2 days, it only picked 2 stocks. This is not what we do usually. Sometimes we do it just because there's enough to account for. But you can see that the number of stocks change, and in 22nd of May, it just chose Oracle, just as an example for you. But yeah, you can see like a lot of you can see the sharp. So the sharp was 2.5 for this time period, while the SP 500 sharp was 1.2. QW sharp was unfortunately negative. As you can see, it's very important. So you can't just guess these strategies. You need to choose them. And sometimes these strategies don't make any sense. Some of them some days they want to maximize the variance. They want to maximize the risk. And we usually don't limit the machine learning model. We just let it run. And maybe it has some non-human way of reading the market. Much like how I think it was DeepMind that beat Go with AI, where the humans were very, very confused by the strategy that was employed by AI to beat a human, the best human at this game. But anyway, so we take the parameter then, the best one of the latest. Usually this needs to be, this needs to be usually the last day, right? We take the last day's parameter, we put it into our solver, and we get a portfolio. So now it's going to give a new portfolio for the next day. I'm not going to do this now because it's not going to be relevant. This is going to be 23rd of May. What we do usually is we take today's date and then trade on that. That parameter that determines what stock to choose. But yeah, that's all we have. As you can see, it produced a new portfolio with Google. So if we were to trade on 22nd of May with this parameter, it would produce this. We also can look at the energies. Usually we want a Boltzmann-like distribution with the tail end here higher, meaning that we are getting close to the ground state. That's all I had. So any questions?
I think there's one in the chat box. Like, have you tried your model in classical computer?
Oh yes, so this was running classically. The demo was running classically. For very, very large universe meaning problem size, number of assets, or a very good amount of granularity, amount of choice for each stock. Here I was just performing an equally weighted portfolio just for the purpose of demo, but you can go and increase your granularity, which gives a bigger problem size. So around 1,000, 2,000 variables, the classical resources start failing, and we go much more beyond that with quantum-inspired resources. Again, we can provide these details on how that scaling translates to the real world to interested individuals or companies.
Yeah, and for rest of audience, if you have questions, you can feel free to unmute yourself or type your question in the chat box.
So maybe we can discuss, like Ricky, we were thinking about how qBraid would allow Icosa to.
Yeah, so if you guys are interested and maybe want to try out parts of this notebook, in the coming months, qBraid will allow you, again, qBraid is a great place to get started and understand a lot of these products that require quantum inspired or just simulated or quantum hardware device accessed notebooks. So we will provide like a simple notebook that you can access that has the environment set up, as I showed, where you don't have to install any additional packages, and it will probably make API calls for it to essentially get you to get started and to learn more about what Icosa does. But if you wanted to actually face them and be an actual client, you would probably have to just contact them as well. So
Yeah,
that will be released. And if you're interested, I have a quick form and you can fill it out as well.
I have a general question. So when you call the quantum hardware, do you have some like queuing issues? How long do you have to wait?
is this question for me or Ricky?
For I think Icosa, yeah.
Yeah, depends on the resource. So some of our resources are not located even in the US. So we go kind of far, a few thousand kilometers across the sea. So there are pipeline delays, but they're not obtrusive because we don't do high frequency trades, we do daily trades. So anything that's few minutes is fine for us.
I see.
Just a comment, the link Ricky sent in the chat box. When I try to open this link, this shows I need permission. Could you double check the settings?
Let me fix that.
Yeah, I think it says the only can be viewed by users in the owner's organization.
Okay. Okay, can you let me actually send a link. It might have changed. Yeah.
Okay, yeah, that works now. Yeah.
Great. Thank you.
Cool. So if there's no more questions, I think that will be the end of today. And thanks for the great talk. Really introduced such good platform and interesting like content inspired algorithm. Yeah, thank you again, and hope to see the audience in the next lecture.
Okay, thank you.
Thank you. Bye.
Yes. Thank you, everyone.
Thank you, everyone.
Bye.
See you.
I'm gonna put my email in the chat if you wanna reach out.
Yeah, sure.
Yeah, we'll put the contact information in the video we upload, and also if you have slides to share, we can also put that on the website.
Thank you.
So
I don't have any slides about I mean I have, but we don't need to put them up. So you can just post, I guess, the recording.
Okay, cool. Yeah, let me store this email address.
Yeah. And just
Okay.
I'm curious, like, what is I believe like Icosa is open for the intern positions. What like what kind of positions like you're opening, or what kind of candidates you're looking for?
So we're very flexible. We choose based on like team fit. I mean, Xiaowei went through that process. She was selected out of 100 participants, applicants. But so her expertise is in finance. We also hired someone whose expertise is more computational architecture side. Another intern who's more experimental physicist. Another intern is more theoretical physics. So it depends. Depends on what we need at the time. But we'll need more talent as we're raising our round soon. So another round. We had pre-seed already, but we're raising our seed round soon. So we're expanding the team definitely.
Yeah, thank you so much. Okay, let's thanks everyone again, and have a good day.
Thank you.
Thank you.
See you.
See you.